All right, welcome to another daily space weather video. We've got a coronal mass ejection kicking off as we do our recording. So the first thing we're looking at here is the sun, the source of coronal mass ejections. We've got two significant sunspot groups in the southern hemisphere, one less significant sunspot group in the northern hemisphere. Likelihood of solar flares is still significantly high here, and we've got a coronal mass ejection occurring from the southern limb as we do our recording. So here's 94 angstroms. Great view there from the SDO in this ionized iron spectra. Here's the colorized magnetogram in 171 angstroms. And here's the GOES 16 SUVI. And you can see this filamentary eruption happening here. Some of it perhaps collapsing back onto the sun. It's too early to figure out the telemetry, but if I had to guess, I would say it'll miss the Earth to the south. And let's zoom out actually to show the whole view here from the GOES 16 SUVI. We did a 21-hour stream yesterday on the Twitch channel. Follow us over on Twitch. You'll get notifications from the mobile app, twitch.tv/smAsho. The 10.7 centimeter radio flux, which is the most proportional data set to sunspot number in terms of solar activity. There it is, the 1 year chart. The black line is the radio flux. It's at 92, by the way. And there's a space weather enthusiast dashboard. No space weather storms or geomagnetic unrest in the NOAA forecast at the moment. Let's blast through some more data. Global seismicity upticked big time yesterday when we saw a 7.5 magnitude earthquake at Peru. It certainly caused some damage and some injuries. No report of any deaths at the moment. I did look up news stories. I didn't find anything too exciting. And a lack of aftershocks happening there. Let's hope that 7.5 magnitude quake was not a foreshock. So I'm just going to scroll up the list here and see what else has been happening over the past 24. There was a very deep quake at Timor-Leste. That one listed at 539 kilometers depth and a 4.9 magnitude. So yeah, a surprising lack of aftershocks there in Peru. I would have been expecting to see multiple 4 and 5 magnitude quakes since that 7.5, but we don't see it on the list. So perhaps that tells us something about what's going on. Leave us a comment if you have a theory. And we're always fascinated by comments where other channels, viewers claim that other channels are forecasting earthquakes. We just don't see it. And we would be very interested in any physics regarding the forecasting of earthquakes. A lot of ridiculous and outlandish claims get made on YouTube. I'll just leave it there. Certainly the channels to which we're referring don't need our help, as both of them have 6-figure subscribers. Drop us a line. We're interested in hearing your claims on the physics and how it is you forecast earthquakes. A deep quake in the Fiji Islands there, a 4.5 at over 540 kilometers estimated depth. And the South Sandwich Islands continue to shake. And that earthquake magnitude, that 7 magnitude earthquake drought ended there. And let's look at volcanoes. We see some activity here at La Palma once again, some significant earthquakes happening, including a 4.8 out in the Atlantic Ocean. So it's still producing a 7,000-foot plume of volcanic ash as well, flight level 070. That 4.8 magnitude quake occurred at 8:35 a.m. local time. Interesting, it was at an intermediate depth of 24 kilometers in between the prevalent shallow layer and the deeper layer at 30 to 40 kilometers. Suwanosejima, located in the Ryukyu Islands, also erupting there, flight level 040. It's a 4,000-foot ash plume. Semeru, on the Isle of East Java, flight level 130 from Semeru. It's a 13,000-foot ash plume. Iliwarung in the Lesser Sunda Islands produced a submarine eruption, so some underwater earthquakes associated with volcanoes, as well as an underwater eruption there. Fuego exploding and producing a 15,000-foot volcanic ash plume over Guatemala. Nevado del Ruiz in Colombia exploding. 9,000 foot taller plume of ash there. It's a 24,000 foot ash plume, flight level 240. Sangay and Revenador, both erupting in Ecuador, producing a 20,000 foot and 16,000 foot plume of volcanic ash, respectively. Sabancaya, weak emissions from Sabancaya in Peru. And Nevados de Chilean continues to explode, 14,000 foot ash plume, flight level 140. Please do not pole vault the caldera. Please do visit the links. And when you hit up the Red Bubble shop, make sure you use the promo code CYBER5 to save 20 to 60% off of everything. Links below the video to that. We've placed it in order of best selling. So if you'd like to place your feet every morning on the face of evil and fraud, pick up a Fauci fraud bath mat. It even conveniently represents the term fraud, the intentional misrepresentation of material facts, universum liberate, and help make Earth not suck again by picking up some merch. Today's featured product is the Mensa products. You can get throw blankets and shower curtains and coasters and comforters and duvet covers and tapestries, posters, photographic prints, magnets, laptop skins, don't forget shirts, leggings, mini skirts, etc. Mensa, make Earth not suck again. It's up to you, not the bureaucracies who've been making it suck with their pathetic, ridiculous, and infantile response to COVID. COVIDiocy. We're hoping it's cured at some point. We're also giving the gift of ringtones at smashomash.com/smashteam. Here's a teaser. Some ringtones there. Again, smashomash.com/smashteam. Those are free, and we'll be putting out all kinds of public posts here throughout the rest of the year in 2021. Thanks to our subscribers, please consider funding the channel via becoming a member at smashomash.com/smashteam. There are 3 different options there. For paid-up members, there's also an unpaid bronze membership, and we've been putting up posts that don't even require login recently. Smashomash.com/smashteam, our replacement for Patreon. It's vastly superior. If you don't believe me, check it out. But in any case, welcome to the Neo-Renaissance. You can find links to the smAsho merch page there. We showed you the Redbubble shop. The Smash Team is also linkable there from this graphical link or from here. Also at the bottom of the page, you can find links to the Redbubble shop and the YouTube channel. Smashomash.com. Welcome to the Neo-Renaissance. Congratulations on realizing that the content exists. Next, some magnetic data here over the past 3 days. We're seeing some pretty low readings here on both the GOES 16 and 17's magnetometers. And it looks like the GOES 16 had to do some maneuvering there, creating some plasma with its thrusters. Those arc jet start and end tabs there represent areas where it may see erroneous data because of using its thrusters. Next, the current sheet. And Earth is in a North Pole one. No changes expected on that. You can see it there in green. That also shows you stereo A and B there, respectively, to the left and right at Lagrange point 5 and 4. Here's the line of sight ecliptic plane field plot. It also shows the solar magnetogram, and you can see the 3-dimensional nature of the heliospheric current sheet. Yes, the sun is blasting out charged particles all the time, and this is telling us the polarity of said particles. It does some wonders for solar forecasting. Here's the line of sight coronal hole plot. You can see a large mass of North Pole-oriented coronal hole systems there. A lot of protons are coming out of that portion of the sun. As the north solar polar field migrates to the other end of the closest star. That's what a solar cycle progression is. And that transequatorial coronal hole likely to produce some geomagnetic effects when those high-speed solar protons make it to Earth. So here's a great view of this in 193 angstroms from the SDO. We'll keep it zoomed out to there, I guess. Very well-defined coronal hole. And again, this whole entire northeastern area is surrounded by coronal holes. All North Pole oriented. So it looks like Sunspot 2901 actually became a beta class sunspot group there for a minute. When we did show prep, it was certainly still alpha class. The most likely place for significant flares would be out of 2898 and 2900 down here in the northwestern limb. Still significant probability of major flares here. Solar flare watch continues with about a 1 in 3 chance to see a major flare. We haven't seen any major flares here, not even a C-class intensification over the past 3 days. No spikes in the proton flux, and none expected despite that coronal mass ejection propagating as we make the video. And we saw some missing data here on the normal real-time solar wind that we usually show, so this time we're just going to show the ACE. And you can see solar wind speed here just over 350 kilometers per second. Solar wind density here around 5 protons per cubic centimeter. And the rest fairly unremarkable there. There was some geomagnetic unrest caused by these periods right here, where we saw some big upticks and some big gyrations in both the density and the speed. You can see the density here actually made it up over 100 protons per cubic centimeter there for a brief period. Looks like some minor coronal mass ejection, some high density clouds of plasma showing up there. And here's the KP index. Again, we saw geomagnetic unrest for the first 6 hours. Today on November 29th, that has subsided quickly down to a KP1. Calm geomagnetic conditions. And here's the last 4 hours. This is Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework. I would expect to see a bit of a subsiding here of the pressure. Pretty homogeneous pressure at the moment around planet Earth, though, at least over the past 4 hours. We'll also show you changes to Earth's B field at the ground level. That was space. Here's on the ground. And the ground magnetic perturbations map is great at showing you where the most likely places for auroras will be. Probably seeing some auroras here in southern Canada, actually. Maybe even in places like Minnesota. Let's let that play through a second time. Geospace delta B would be changes to Earth's B field. The scale here is nanotesla magnetic flux density. Know your units, folks. Know your units. Whenever expressing any science data, express the units, or we might not know what it is you're talking about. That's 4 hours of data like the magnetic moment from space. Speaking of space, here's where the solar system objects are currently located. Let's do a 1-week forecast. There's where things will be on December 6th. And here's a star chart. The sun will be passing through Libra and Virgo and Leo, and setting in Taurus after passing through Gemini. That yellow line is the ecliptic. We're using in-the-sky.org. You can see that blue line is the galactic plane. The sun will cross the galactic plane just before setting here in Lehigh Valley, Pennsylvania. Today's cosmology segment is going to be brief. Check our playlist for lots more. You can find links to our videos below this one. Today's random number is 61, which coincides with this pulsar. Pulsar J0146 plus 61. There are its X-ray outputs. And you can see it's actually been getting a little bit more interesting here in the past 30 days. Although over the past 16 years, it's a pretty consistent X-ray source. Some interesting facts about this one is that it's very dark in the entire frequency, in the entire electromagnetic spectrum, except for in X-ray. So here it is on the 2 mass, and there's pretty much no signal there in infrared light. Here's the pan stars. The high-resolution optical survey here in bands Z and G. It's a dark part of space there as well, where that pulsar is located. When we look at it in ultraviolet, it's still a dark portion of space. No real signal there in ultraviolet light, but when we bring up the X-ray data, it is indeed quite bright. So there's that pulsar. Again, that is entry number 61 at the Neil Gehrels Swift-Bat X-ray Observatory. It's pulsar J0146 plus 61. And this is what Neil Gehrel's transients page looks like. Again, that's entry 61. Pulsar J0146 plus 61, another catchy name. And there it is in X-ray. Let's talk about something a little more interesting. This spiral, it's a binary star system. And interestingly about this is that these coincide with about 800 years. That's about 800 years. That's about 800 years. That's about 800 years. And it appears that that periodicity coincides with the orbital periodicity of the binary system. That's the astronomy picture of the day, and it's quite spectacular. And at apod.nasa.gov, you can read about it. There's a little caption there that object is known as LL Pegasi. And it's not fully understood why this is illuminated the way it is, but it is certainly an interesting binary system, LL Pegasi. The spiral nebula associated with it. And if you've got theories as to how that's working, one of the theories is, by the way, that local stars are illuminating this spiral. Perhaps we're looking down the polar jet of the binary system, and perhaps the two stars have coinciding binary polar jets. Who knows? One of the things about cosmology that's pretty interesting is the outputs of stars. We just looked at some outputs of stars, most likely. Some plasma features being created by the orbit of those binary stars. Let's take a look at what's going on at our star. And you can see the coronal mass ejection starting to propagate here. So this is the difference imagery, and you can see it coming out there, as well as on the raw data on the left. That's the coronagraph at stereo A located out here at Lagrange point 5, which puts Earth off to your right. Again, if I had to guess, which I don't, I would expect this coronal mass ejection to be missing the Earth in a southerly direction. That's today's cosmology segment. We kept it in the space weather video. Incentive to watch our other daily space weather content. We've got many cosmology segments integrated into the daily space weather videos, as well as over 200 cosmology segments on their own playlist at youtube.com/smAsho/playlists. Let's take a brief look at charging hazards. So we don't see any. Satellites are looking pretty safe at the moment. We're seeing some chaos in the electron belts and the ionosphere. We'll get to it. First, the one-year chart of relativistic electrons. There you have it from Solon.info to put it all in context. And here's a 3-day chart. We're seeing a bit lower levels here. And there's the NOAA forecast for relativistic electrons, expecting even lower levels, in which case we'll see even more chaos in Earth's Van Allen belts. And when we're talking about Earth's Van Allen belts, we're mainly referring to the inner one, in that your GPS satellite must communicate through this band of electrons. And that affects GPS signal propagation. It can cause GPS errors, and we're seeing some big-time GPS errors here over places like the Pacific Northwest, a lot of North America. Large portions of the planet here are seeing GPS errors when they're not expected. Usually they happen around the equator at noon. And as we've shown regularly on the channel, we see chaos where electrons are sort of out of place when the electron flux is at low levels, and they're more organized when we see higher electron flux levels, perhaps giving us some additional insight into the physics of what's going on around the planet, in space, maybe even inside the inner workings of the planet Earth. Next, a diagram of the atmosphere showing the F ionosphere layer. Here it is, the vibrational frequency thereof. And you can see quite a bit of anomalies here, mainly in the southern hemisphere, mainly of the high frequency nature, but also low frequency anomalies around the equator. If you're not used to looking at the data, that's okay, because we're going to show you the anomalygram anyway. And if you're a new viewer, congratulations on realizing that the channel exists. Don't forget to press share. Share on your Feces book page. Feces book, powered by Meta. They censor us. Do they censor you? They love when people share our content. And tell Borg drone Mark Zuckerberg we said hi, and that his metaverse idea is hilarious. So check it out. Wild swings in the ionosphere around the South Pole. You can see high and low frequency anomalies happening there. around the Drake Passage as well. So quite a bit of ionospheric anomalies occurring here. Anyway, here's the latest image. That's 12 o'clock Universal Time, 12 noon, Greenwich Mean Time. And there is the anomalygram. That's departure. That's anomaly in megahertz from the 30-day median. You can see some low-frequency ones happening over the central Indian Ocean at the moment. What about bonus features? We've got them, as we do on the regs. And the first bonus feature is the Cerro Tololo, Chile, ground-based solar observatory data. And surprisingly, we're not seeing this filament vanishing down here. The data is only 2 minutes old, at least the last images. So let's continue on here. Here is the latest intensitygram and latest magnetogram. So you can see this sunspot here is significantly likely to produce major flares. This one a little bit less so. This has got 2 major umbrae. This one up here looks like it's alpha class to me. Here are the fields. Again, significant possibility for major flares here, especially out of that sunspot right there. And here you'll be able to see this filament ejecting just ahead of this coronal hole here, actually. Great view of that from this composite imagery. This is 211, 304, and 171 angstroms in green, red, and blue, respectively. And we'll close out today's daily space weather video on 304 angstroms. Great view of that filamentary eruption. Again, if I had to guess before seeing enough telemetry on it, I would say that it's probably going to miss Earth to the south. So thanks, viewers, for tuning in, and may that solar wind be at your back.